Hello, guys. If you know yourself that you're struggling with physical science, you're struggling with maths, you're struggling with geography, life sciences, you have came to the right channel. So, in this video, we'll be covering Newton's second law questions. Right here on my screen, I have 2015 question paper from grade 11. And this question 4 is talking about what Newton's second laws. Now, let's go ahead dive into the question. Before we do that, don't forget to subscribe to the channel, guys, and like the video. Share it with your friends to see more content. And also, let's pass together. Okay. Now they're saying in the diagram below, a 2 kg block is connected to a 1 kg block by a means of a light inextensible string. The blocks are pulled up an inclined plane which forms an angle of 28 degrees to the horizontal. The sides of the blocks which touch the inclined plane have the same area. The kinetic frictional force between the 1 kg block and the inclined plane is 4 newtons, while the kinetic frictional force between the 2 kg block and the inclined plane is 8 newtons. Now, let's go ahead and solve the questions that we are given. So, what are we dealing with? We are dealing with Newton. We are dealing with Newton's laws, guys. Don't forget that. We're dealing with Newton's laws. Newton's laws. Okay. Fine. Let me go ahead and use a pen. I have a question there. Right. Forgive my diagram, guys. It's a little bit messy, but it's fine. Okay. Now the first question. First question says to you, draw a labeled free body diagram showing all the forces acting on the 1 kg block, right? If you go ahead and look at the 1 kg block, you would see that the block is on a surface. And remember, a force that acts on an object that is on the surface perpendicularly, so it's called what? A normal force. And when I'm going to draw that normal force, I will show the marker that because this 1 kg is at an incline, I will tilt my line a little bit to an angle of 28 degrees. But because you can't draw the angle of 28 degrees precisely with your hand, just show the marker that you have tilted your line a little bit like this. All right? Okay, so our question is what? 4.1.1. So I will have my solid dotted line here that will fit all the forces, and then I'll just show the marker that my normal force is tilted, right? Fine. Then I will also show the marker that there is a force that is being applied upwards in the right direction, which is what? 30 newtons. So I will tell my marker that my force applied is 30 newtons, right? And remember, because this system of two blocks is accelerating or is moving upwards, right? It means that my force applied have to be longer. The line has to be longer than all the forces that are acting in the opposite direction. So whenever I'm going to draw my force applied, I'm going to go ahead and make sure that it has a longer line. So I'm going to call that FAP, or force. The F stands for force applied, right? And then obviously on my diagram, as you can see, guys, on my diagram, I have tension that is acting between these two blocks. There is a tension that is acting between these two blocks. So whenever a string is connecting two blocks, the force that is acting on this string or a rope or a wire, anything, it's called a tension force. So I'm gonna show my marker with a solid line, guys. Please, when you draw your tension, but it must be shorter. With a solid line, I'm gonna tell my marker that the force applied here on the string is called tension. And again, they told us what? That on the 1 kg block, the kinetic frictional force acting between the 1 kg block, right? The kinetic frictional force acting on the 1 kg block is what? And the incline is what? It's 4 newtons, while the one for the 2 kg block is 8 newtons. So I already know that because my frictional force is a force that opposes the motion of a moving object, therefore I will have to show my marker again that the kinetic frictional force is also acting in an opposite direction to the motion. So I'm gonna call my kinetic frictional force what? Fk. Now there are two options that you can draw this free body diagram. You can firstly say to the marker, I am smart and I know what I'm dealing with. Please note that my gravitational force is acting perpendicularly and parallelly. So I'm going to tell my marker that since these blocks are on an incline, therefore the frictional force, the gravitational force, sorry, is acting in the y direction and also in the x direction, right? So I'm going to tell my marker that when the weight or the gravitational force is acting in the y direction, it's called the FG perpendicular. FG perpendicular is represented with this symbol, right? And then I'm also going to show my marker that the FG also is acting on this block in the x direction, and this FG is called what? FG in the parallel direction, right? This is the first option of drawing your free body diagram. The second option you can do is still the same thing. You are still going to have your forces normally. You're going to have your normal force that is tilted a little bit. You're going to have your longest force applied. You're going to have your tension here, right? You will still have your kinetic frictional force. But for this second option, I'm going to call this my second option, right? For this second option, you are only going to have the gravitational force, which is acting at an angle. So you're going to tilt. You see what I did with my hand there? I just tilted it at an angle, my FG. So you showed the marker that my FG is acting in a little bit tilted way rather than breaking it into components. But I always advise you guys that always make sure that you break it down in components. So I don't advise this method. I approve this one actually, because you will never go wrong with the first one. Okay, now the second question says to us, now state Newton's second law in weights. Remember they said what? In weights. Fine. So when we state Newton's second law, what does Newton's second law say? It says whenever you have an object that is moving or it's in motion, the acceleration of that object is directly proportional to the force that is being applied to the object, right? But that acceleration is inversely, or also the force is inversely proportional to what? To the mass of that object. So we're gonna go ahead and write Newton's second law in weights. When a force is applied on an object, the object will accelerate in the direction of the force. This acceleration is directly proportional it's directly proportional to the force and inversely proportional to the mass of the object. Fine, now you get your 2 marks and you move. Always know your laws, guys. And then they're saying calculate. Now this is the important part that I like. Calculate the magnitude. Now they're saying to you calculate the magnitude of the tension in the string connecting the 2 blocks. Okay, now let's just turn to the next page there. Okay, now our 4.3, right? 4.1.3. For us to calculate that, let's quickly look at our diagram. Oh, we can also see the diagram here. Okay, nothing has changed. Okay, yeah, because the top one is still a little bit messy. Let's deal with this one. Still the same thing, right? So when you want to go ahead and calculate your tension that is acting in both of these 2 blocks, the tension that is on the string, you want to go ahead and break down this system into different parts, right? What is the system that I'm talking about? Because now the question is different. Here is it. Sorry guys, here is it. So you're gonna go ahead and deal with the forces that are acting on the 1 kg block only, and then also deal with the forces that are acting on the 2 kg block only, guys, right? So you're gonna go ahead and tell your marker that for 1 kg block, now what do I have? What do I know about the 1 kg block? Okay, my examiner told me that the 1 kg block is being pulled by what? By a force of what? 30 newtons. The force that is being applied is what? 30 newtons, right? And then also my 1 kg block has a tension that I don't know, guys. Okay, note that. And then my tension also has what? Remember, when we're dealing with such questions, we always consider the horizontal components only, and we neglect the vertical ones. What are my vertical ones? Is my gravitational force and the normal force. We neglect those ones. We deal with the horizontal ones because the force, the system is moving horizontally, not vertically, right? Okay, always know that. So what do I know? I also know that I have a kinetic frictional force that is opposing the motion of this block, and it's what? It's 4 newtons. It's 4 newtons. Okay, so I want to go ahead and tell my marker that now I've discovered the forces that are acting, but I also know that there is a gravitational force that is acting in the parallel direction, right? And remember, this gravitational force is calculated by what? Mass multiplied by the gravitational acceleration, because it's acting in a parallel direction, and there is also an angle. Gravitational force, when it's acting in a parallel direction, right, you're gonna add your trigonometric ratios, which is your cosine, your sine, right? So remember from vectors and scalars. From vectors and scalars, the forces that were acting in the x direction were called, if they're acting on the x direction, there's an angle, they were the angle, the trigonometric ratio that we're using is the cosine, right? And then for the y ones, we were using the sine. Now here's a twist. For Newton's laws, we are going to use what? For the parallel direction, we're going to use the sine, and then for the perpendicular direction, we're going to use what? The cosine, guys. Okay, so now I know that now I will call this mg sine theta. And then what is my sine theta? Is what? Is 28 degrees. It's 28 degrees. So I'm gonna say my equation is what? Mg sine 28 degrees. Now let's go ahead, solve the system for 1 kg block. So you're going to, because we're dealing with Newton's second law, you're always going to tell your marker that I know my equations, and then my equations are what? For Newton's second law questions, F net will always be equal to MA, like we defined it on top, right? So what does F net mean? F net means the resultant force, all the forces that are acting on your 1 kg block. What are all my forces that are acting on the 1 kg block? Is the force applied, is the tension, is the kinetic frictional force, and then is the Fg parallel, right? Now, always consider the direction of motion as positive, because my force applied is the direction of motion, is moving in, is being applied in the direction of motion. All the blocks are moving upwards up the incline. Therefore, I will consider my force applied as what? As positive. Okay, force applied as positive, plus all the forces that are acting in a different direction. What are all the forces that are acting in a different direction? It's my tension. I put it in a minus sign, and note that I'm putting them inside brackets, plus what? My kinetic frictional force. I also add a little bit of negative there to show that it's acting in a different direction, plus my Fg parallel, a little bit of negative there, and then it's equals to MA. Let's do quickly our math. We all know that since we have the negatives in these brackets, we're gonna have negative tension, plus multiplied by negative is a negative Fk, and also minus Fg parallel, right? It's equals to ME. Okay. Now, okay guys, now let's continue. So I know that my force applied, they told me in the question that they showed me even in the diagram, what is the force applied? The force that is being applied there, it's what? It's 30 newtons. So I'm just gonna go ahead and write 30 plus minus tension, I don't know it, minus the kinetic frictional force is what? It's 4, minus what? My Fg parallel. And remember, Fg parallel we represented by what? By the mass being multiplied by sine theta. All this equals to, what is the mass here? We're dealing with the 1 kg block, right? So it's 1 times the acceleration. So we can actually go ahead and call this acceleration, because 1 times a, it will be a. Okay, now the reason why I didn't substitute here is that I want to clear out these things out of the brackets. So I'll have my 30 outside. Positive multiplied by a negative, it's actually a negative, so I'm going to have negative tension. Positive multiplied by a negative is actually a negative again, so I have -4. Then positive multiplied by a negative is I have now minus mg sine theta. Now I'm free sine theta. Now I'm free from my whole brackets. Let me get the a closer. Now I'm free from my whole brackets. Okay, now let's deal with solving the question now. Okay, now what do we do now? We have 30 minus the t minus the 4, and then what is my mass? My mass is 1, because I'm dealing with a 1 kg block. Should have wrote here that for 1 kg block. And then what is the gravitational acceleration? Is 9.8 sine. What is the angle of inclination? The angle of inclination is here, is 28 degrees. Then equals to a. Remember, where did I take my a? My a, I got it here. I said, when I substituted the mass, I said 1 times a and gave me a. Okay, fine with that part. So 30 minus the t minus 4. We can actually work out this. So in your calculator, you're going to say, in your calculator, you're going to write this. You're going to say -4 minus 1 into 9.8 sine, or is your sine 28. Okay, now it's giving us -8.60. We can work with that. It's a, right? Now you're gonna go ahead and take this number, the -8.0, and minus it to the 30. We're gonna say 30 minus this number. No, we're not going to say the 30 minus this number. We're just going to say, yes, we're going to say, I'm sorry, we're going to say the 30 minus this number, because actually the minus is already there. It already has the minus, so technically that's what I'm trying to say. Okay, let me quickly press my calculator there. 30 minus this number. So if I minus the 30 from this number, I should get this. I should get 21.4. Let's round it off to 2 decimal places. So I'm gonna write the 21. No, did I say 30? 21.40. Now minus what? Minus your tension equals to a. Okay, now I want to make my tension the subject of the formula. What do? I say my minus tension is equals to the a. I transpose and take this number to the other side. Now I have what? It becomes a negative when it goes the other side, right? PC is shutting down. Okay, it's 21.40 minus 21.40. But because I want to remain with t, I'm going to go ahead and divide by a negative all sides, or just technically by a -1. Okay, so still the same thing. Even if I don't divide with a -1, I'm just saying a negative, still fine. I divide by a negative, the negative will cancel the negative. Negative divided by a positive of this a, we're going to have what? Minus a. And then negative divided by a negative is actually a positive. You saw also here, so we're going to have plus 21.40 here, which is close to the tension. That's my equation 1, guys. Remember, we're dealing with simultaneous equations when we're solving Newton's second law questions. Okay, now for the 2 kg block. Now I'm dealing with the 2 kg block now. Okay, what are the forces that are acting on the 2 kg block? In the direction of the motion, where are the blocks? Okay, here are the blocks. So the 2 kg block, in the direction of the motion, tension is acting upward, up the incline. There's also a kinetic frictional force that is opposing the motion. There is a gravitational force that is being applied perpendicularly and parallel, and then the normal force. But let's ignore the vertical components. Let's focus on the the horizontal components. So for the 4 kg block, you're still going to tell your marker that F net is indeed equals to MA. Okay. Okay, my mass. What is my F net? All the forces that are acting on this object. But now my tension in this example, in this case, right? My tension right now is acting in the direction of motion. It's in that way now. For the 1 kg, it was in the opposite way, but for the 2 kg now, it's in that way. So I'm gonna say all the forces will minus the tension. So the tension now is positive, okay? Plus all the forces that are going in the opposite direction. While the forces that are going in the positive direction, we put a minus for them, is minus the frictional force, plus minus the gravitational force that is acting in a parallel direction. What else do we have? Yeah, that's all. Okay, now I can, okay, this time around, to avoid mess, let's just remove the brackets quickly. Okay, now removing the brackets, we're gonna say the plus multiplied by a negative, it's a negative fk, a plus multiplied by a plus, it's technically a plus, then multiplied by a negative is a negative, so we're gonna have minus fg parallel, which is equals to ma. Now I'm left with this, right? Now let me quickly substitute. Okay, now what is the gravitational force? Not the gravitational force, sorry. The frictional force that is acting on the 2 kg block is the 8 newtons. So I'm going to go ahead and write what? 8 newtons, right? Minus what? Remember, Fg means mass multiplied by gravitational acceleration. What is the mass? Is 2 kg. And the gravitational acceleration is always 9.8. Because it's in the parallel direction is sine. What is the angle of incline? Is 28 degrees. What is the mass? Is 2. And then acceleration, of which we don't know. We can punch this number in the calculator. You can say now on your calculator you have to punch this. You will say minus 8 minus 2 into 9.8 sine 28, and you should get minus 17. You should get minus 17.20. You should get that, which is equals to the 2a. Now I'm left with this. Can you guys now see that things are getting together now? Okay, now I want to make my tension the subject of the formula. What do? I just take this number to the other side, and then when I take this number to the other side, it becomes a positive 17.20. Now this is what my second equation. Why? Because I've made my tension the subject of the formula. Now tensions are on the same side. Since that is the case, we can literally say we will let equation 1 equal to equation 2, because why? We're dealing with simultaneous equations. So we're going to say, what is my equation 1? My equation 1 is tension is equals to minus T plus this whole number. So basically this equation 1 is equals to equation 2. It means that tension is equals to tension, not T2. Tension is equals to tension. What is the tension for equation 1? It's what? Minus A plus 21.48 is equal to this number. What is the tension for the second equation? Is this, the 2a plus 17.20. Okay, now we can solve for a, and then so that we can find our t using either of these two equations that we found. Okay, now let's quickly do that. What can we do? We can literally see that 21 is bigger than the 17, right? So we can be qualified to say that we can take this 17 to the other side and minus it to the 21.40. So minus 17.20. And this other side, because the 2 is bigger than the minus a, we're doing math basically. So we're going to say 2a, and then we take this minus a to the other side, and it becomes what? A positive a. Now we're going to have 3a here. Let's quickly minus these two numbers and see what we get on our calculator. Okay, we're going to say 21.40 minus the 17.20, and then what do we get on our calculator? We get 4.2. Let's write it to 2 decimal places for 4.20, right? Okay, now because we want to remain with a only, we will divide both sides by 3. Divide both sides by 3. 3 will cancel 3, and then this number divided by 3. Now our acceleration is equals to what? Our acceleration is equals to 4.20 divided by 3, which is what? It's 1.40. Remember, always write your numbers to 2 decimal places, meters per second, right? Now we found our acceleration. Now, what do we do when we found our acceleration? Remember, the question said to us, let's find the tension. It didn't say find the acceleration. Now, you are almost done when you got your acceleration. We found our acceleration to be what? Our acceleration, acceleration is 1.40 meters per second. Okay. Now, in any of these equations, we can substitute our a, and it has to give us the same answer. So our tension, when we substitute it, when we say not the tension, when we substitute a into equation 1, it has to give us the tension, the unit for tension, the number that they want. Okay. Now, because a there is negative, we're going to say negative 1.40 plus what? Where's the equation for? Okay, plus the 21.40. The number that you get here must be minus 1.40 plus the 21.40. It has to give you 20. Wow, 20 newtons on the dot. 20 newtons. Let's see if we substitute it on the second equation. Substitute a into the second equation. Let's see. Tension will be equals to, what is the second equation? We found it here. I don't know if you guys can see it. It's here. So we're going to say 2 into 1.40 plus the 17.20. Sorry guys, 20. So we're going to have 2 into 1.40 guys plus 17.20, and then you still get, voila, do you see? Do you still get what? 20. Then it means what we did is correct, 20 newtons, and then you get your 5 marks in the back. Simple as that, guys. Was it hard? No, I don't think it's hard if you follow your steps. Let's continue with the questions. We're almost done with question 4. Okay, and then we move to 4.1.4. Now 4.1.4, it says to you, the two blocks are interchanged so that the same 30 newtons is now acting on the 2 kg block along the inclined plane as shown in the diagram below. Okay, How will the acceleration of the system change, right? Only increase, decrease, or remain the same, right? That's what they're trying to ask here. Take note that even if we change how the blocks are being positioned on the incline, as long as the 30 newtons was able to pull these two blocks before, because the masses of these blocks didn't change, the tension will remain the same. So tension is independent of the position of the blocks, how they are situated, only if the masses of the blocks didn't change. Because the masses of the blocks didn't change, the force applied, these two blocks, the system is still, all in all, the system is 3 kg. It will still need 30 newtons to be pulled up, no matter how we put these two blocks. So our answer will be what? Remain the same. Because why? The mass didn't change. So that mass to be pulled, it will still need the same 30 newtons. So our answer is remain the same. Okay? 4.1.4. I know you thought it would increase, it wouldn't. Okay, now 4.1.5. It says, how will the tension in the string connecting the two blocks change, right? Only increase, decrease, or remain the same. Okay, now because here's a twist. Now we're talking about the tension, right? Because let's say you're connecting this pen, guys, right, with this calculator, and then I'm pulling them in this direction, right? Obviously this pen is pulling this calculator, right? It will not need too much tension to be pulled, right? But it's still pulling this calculator. But if I change now, I'm saying this calculator, let it pull this pen, I will need to increase my tension. The rope has to have more tension to pull this calculator. Why? It's heavier than this pen. Therefore, when I change the masses, the position of the masses, the tension does what? Changes. Why? Because the more the mass of an object increases, the more the force that is being exerted on the rope or the string increases also, because it needs, now we need a greater tension for this big huge block to be pulled. So what will happen? The tension would do what? Would increase. Why? Because right now the 2 kg is way heavier than the 1 kg. So our tension would do what? Increase. And then our tension would increase. Okay? All right. Whew. Now let's move to 4.2.1. 4.2.1, guys, it says to you, in the diagram below, a mass of 1 kg. Oh, we are done. Yes, we are done. Oh, okay, almost done with question 4. 4.2 says to you, in the diagram below, a 1 kg mass and 2 kg mass are connected by an inextensible string. They like that. Of an neglectable mass, right? We neglect the mass of the string, okay? The string is passed over a light frictionless pulley so that the masses hang down as shown. Initially, the system is held stationary. The system is not moving. Initially, what do they say? Initially, the system is held stationary. So the system is not moving, okay? Now they're saying 4.2.1, draw a labeled free body diagram for all the forces that are acting on the 2 kg block. Now, since now this, please note that on this one, the system was accelerating, the system was moving on a horizontal plane. Now this system is moving on a vertical, I would say a vertical way, a vertical motion, right? So what does that tell you? It tells you 4.2.1. When I'm going to draw my free body diagram, I'm going to show them that there's a tension that is moving, right, upwards. And there's a force that is pulling down always objects. It's what? Fg. But note that because these blocks are just hanging, there are no horizontal forces. Why there are no horizontal forces? Because these blocks are hanging and they are not on a surface. So if they were on a surface, we were going to have our frictional forces, or force applied, all that, as you saw them in this example. But right now, because they are hanging on a pulley, there are no horizontal forces. So we're dealing only with vertical forces, right? Okay, now they didn't tell us where the system is moving. So I'm just gonna consider my tension as being the positive one. So my tension is going upwards. Okay, for the 2 kg, I'm gonna just show them that my tension is going upwards, and then my Fg is gonna be a little bit smaller because the system has to move eventually. So this will be the free body diagram. That's why it's 2 marks. You mark your tension, you mark your gravitational force. That's it. Then they're saying 4.2.2, calculate the time. I like this question. Calculate the time it will take the 1 kg mass to move a distance of 1 meter when the system is released. Okay. Now they gave us a distance. And what do you remember about distance? Equations of motions. Yeah, they're going to work here. And equations of motions, they only work when you only have what? Your acceleration. So we need the acceleration here. Okay, let's find the acceleration of these 2 blocks. That's why it's 7 marks, guys. You always tell by the marks that here I'm going to work 7 marks. Let's do what we did there for the previous question. So for the 2 kg block, let's deal with the 2 kg block. Okay. So I'm gonna have a tension minusing the Fg, because Fg is opposing the motion, guys. Okay. It's opposing the motions, and it's gonna be equal to ma. Remember, F net is always equal to what? Your F net, I don't know if you guys can see, sorry. Your F net is equals to ma. Okay, now let's substitute. Fg is measured in mg, right? Remember, we don't write any signs and any thetas here, because why? We are dealing with something that is on a vertical plane. Okay, so our Fg is mass times the gravitational force. Our mass is 2, the gravitational acceleration is 9.8. The mass is 2, this is a. Let's make t the subject of the formula. T, okay, let's quickly type in our calculator. What is 2 multiplied by 9.8 is 19.6, guys. So we're gonna have minus 19.6, which is equals to 2a. You transpose your 19.6 the other side, it becomes a positive, so it's 19.6. Okay, that's our equation 1. Voila. For the 1 kg block now, for the 1 kg block,